The CLO for this lesson is that students will be able to create, in writing, exponential equations using interest, as well as the following language: if-then statements, exponential, interest, principal amount, APR, and compound. So, in your own words, what do you think you're going to learn how to do in this lesson? All right, so if we begin with our vocabulary words, remember if-then statements is just how I want you to speak at the end when you paraphrase what you've learned. So you might say, if the equation's an exponential and has this interest, then blah, blah, blah. And then you'll try to use these vocabulary words. So remember, exponential is just an equation where the exponent is the x. So x goes up in the exponent. And the reason why it goes up in the exponent is because exponentials are multiplicative, meaning we multiply by the same number every time. And so since x is our time, exponents tell us how many times you multiply something to itself. So that's where x goes for exponentials. Then these are our new words. So if we start taking notes, the word interest is money someone earns. So interest is money someone earns. You can earn interest by letting a bank borrow your money. So you give them money and they hang on to it. And as long as you don't touch it, so they're borrowing it right now, they give you back money later on because you let them borrow some of your money. But then in the reverse, if you borrow money from somebody else, like let's say you borrow money from the bank, then the bank earns interest. So it's money someone earns because someone borrowed money from them. So as long as they still owe money, the lender earns a small amount called interest until all of the money is paid back. Examples. So there's some interest examples. For example, you borrow money for a car. Every month, when you make a payment, a little bit of that money is called interest. It's extra money on top of what you owe them, because you're still borrowing money. So this is true. Interest gets applied for any time you borrow money ever. If you want to borrow money for a car from the bank, if you want to take out a loan for a house, if you want to take out a loan for college, anytime you're trying to borrow money from anybody, they always are going to charge you interest. So this lesson is super real world, because in your life, always, if you're borrowing money from the bank or from anybody, they are going to charge you some kind of interest. So this happens on credit cards. It happens anytime you borrow money. So you're not only paying back what you borrowed each month, you're also giving them a little bit extra to say, hey, thanks for letting me borrow it. It gives them a reason to lend you the money. The only reason why they're lending you the money is so that they can make money off of you. Like there's no reason for them to give it to you if they're not going to make interest because of it. So that's the only reason why they even let people borrow money, is so in the long run they can make more money off of you. In the reverse, you can loan people your money too. Another example is, let's say you invest money into the stock market. You could also invest money into the bank, like into a savings account. Here, let's do a savings account. Into a savings account. Well, technically, when you hand the bank your money into the savings account, it's not like it's just sitting there. They take that money and they use it. They put it places. However, when you look online and you look at your bank statement, it looks like it's there, but it's not. It's really not just sitting there. They went and they spent it elsewhere. And so when you take your money back out, they're giving you someone else's money. It's not the exact same bills you put in there. And so because you're letting them hold on to your money and borrow it for the moment, a lot of savings account will give you a small amount of interest back. So over time, you will earn a small amount of interest for saving the money. So that's the thing about savings accounts. The reason why they're different than a checkings account is because a checking account, you pull money from, you put money in, it goes back and forth. You're meant to make lots of transactions. For a savings account, you're only allowed to make like 5 withdrawals per month because they don't want you to take your money out. The point of a savings account is for you to save it there. And so as long as it's sitting there and you don't touch it, you might only earn 1 penny a month, but you're slowly going to earn some money on that amount that you're saving from the bank. There's ways to get more interest because a savings account is usually a really tiny amount of interest. But you can invest your money, like I said, into the stock market. And then you might, it's a risk because you might lose all that money, but you might make back a big amount of interest depending on what happens. There's also other things that you can invest money into as well that will give you money over time because you're technically loaning your money to somebody else. And so, yes, this is how the rich people play their games. They borrow a lot of money and then they loan out a lot of money and they are constantly playing this interest game. It makes a big difference. Yeah. So this is what interest is. There's some other big words we need to define, like, for example, your principal amount. Whenever you're working with money, the word principal means how much you start with. So it's just the starting. Principal is another word for starting. When we're talking about interest, the APR stands for annual percent, the annual percentage rates. So this is the big word for interest. So annual means yearly, for yearly. Percentage means it's going to be given into percent, and the rate just means how much. So this is how much is your interest in a percent. So it's your yearly interest. So every time you take out a loan or you invest your money into a savings account, they're going to give you an APR, which just tells you what kind of interest you're going to either be getting or paying back, depending on the situation. Well, that interest can sometimes be compounded. It doesn't have to happen only every year, even though it says annual. So your APR is a yearly amount. But sometimes they can divide up that yearly amount and do it more than once. They could do it yearly, but they could do it monthly, which would be they compounded it 12 times. So remember, compound is how many times they apply the interest in a year. So if they do it yearly, it would only be 1 time. So once a year, that interest is applied. But they could do it monthly, where they take the interest and divide it by 12, and then do it 12 times a year. Quarterly means every season, because there are 4 seasons in a year, 4 quarters. So there's summer, fall, winter, and spring. So it happens every 3 months. So quarterly happens 4 times. Think there are 4 quarters in a dollar, 4 quarters in a year. If it's happening every week, that means it's happening 52 times a year, because there's 52 weeks in a year. And if it's a daily compound, it's happening 365 times in a year, because there's 365 days in a year. So it's happening every day. That's how many times it happens per year. So these numbers beneath are how many times it would happen per year. So if it said compounded yearly, it would be once. Versus if it said compounded quarterly, it would happen 4 times. So we're gonna talk about what this means in this example. So it says you put $250,000 into a savings account. So you're investing your money to the bank. And there, with an APR, an annual percent rate of 15% that gets compounded every month. And they want to know how much money you'll have after 5 years. So we're going to go the long way first. So we're going to figure it out first, and then I'm going to show you the short way. So here's the long way. Your starting amount after 0 time is $2,500. Well, remember time is in years. It says after 5 years. So right now, here I'm going to write this. X, remember points x, comma, y. And remember, x is always about time and y is always about amount. So in this situation, our time is in years. And the amount we're talking about is how much money we have. Which is why after 0 years, our starting amount is $2,500, which means remember the big word for this is principal amount. So because we're dealing with interest, we can call it the starting amount or the principal amount. So the principal amount is $2,500. So here's what's going to happen to my money. That $2,500 is going to get added on because I'm earning 15% of it every month, except I don't get 15% each month. That 15% is my yearly interest rates. So going away from my little table for a minute, and I'm just going to write some math. I get 15% each year, but it's being compounded monthly. So I need to take that 15% and divide it into 12 months to figure out if this is my yearly percent rate, what is it going to be each month? So if I do 15 divided by 12, the answer is 1.25% each month. I have my $2,500. I need to figure out what 1.25% of that is. Like, how much am I going to get? Well, remember the word of in math means multiply. So I need to multiply 1.25%. However, I can't just multiply percents like this, like as a whole percent. As an example, what's 50% of 100? Well, 50% of 100 is half of it, and so that's 50. But in the calculator, if I typed 100 times 50 for 50%, that does not say 50. That says 5,000. Remember, always before you do math, you have to turn your percents into decimals first. So to go from percent to decimal, in case you forgot, you end up dividing by 100. Or you might have been taught to move the decimal back twice. It works in the same way. If I take my 50% and divide it by 100, I realize my decimal is 0.5, which is why for 50% you do times 0.5. 100 times 0.5, so 0.5 times 100 is 50. So in the same way, I can't multiply my starting amount by my percent. I have to multiply it by the decimal. To turn it into a decimal, I take 1.25 and I divide it by 100 and figure out it's 0.0125. 0.0125. And so when I multiply this amount to my 2,500, I'll find out that 1.25% of that amount is only $31.25. So after 1 month, so it's not 1 here because remember my time is in years. So a month is 1 out of 12 because there's 12 months in a year. After a month, this is not how much money I have. I don't put that answer right here. That's how much interest I made. So I need to add this amount to the 2,500 that I already started with. So when I add that 2,500 that I started with to the interest I earned, I now have a total of $2,531.25. So after 1 out of the 12 months in a year, this is how much money I have. So when I do the second of the 12 months in a year, now I have a new starting amount. Now this is how much I have in my bank account. I need to multiply that by my 1.25%. So because it's getting compounded monthly, each month they're going to give me more money. And so then I get to multiply my interest rate to my new amounts with the $31 they gave me from last month's interest. So remember, to do that, I actually have to multiply it by the decimal, not the percent. So I had to take this decimal. So I take this number and I say, okay, so what is 1.25% of that by multiplying it to the decimal? And I'm like, oh, now it's $31.64. See how that's only a little bit more than last time, but still, it's a few cents more interest because I had a little more money in there. But I still need to add my interest to the whole amount that I had before. So I had this amount a month before in the last month, but I'm earning this much interest on it. So I need to add that on. And so here is my interest, but I'm adding the $2,531.25 that I had from last month. Now I'm at $2,562.89. $2.89. So this was after 1 month. This is after 2 months. I want to do after 3 months. After 3 months. So my new amount here that I have is I have $2,562.89 that I need to multiply to my now monthly percentage rate after I divided. Turn that into a decimal. And so this much, my new amount is how much I'm going to add to my interest once I figure out what my interest is. So to figure out that interest, I'm going to multiply here. So I'm going to take this and I'm going to times it by 0.0125. To figure out the interest I'm earning now is $32.03. That I have to add on to my previous month's amount. To find out now that I have $2,594. 92 cents. Here I forgot to write this answer. The answer we got after month 2, after the equal sign. So it's a little more money. So after 3 of the 12 months in the year, I have that much money. I'm not even at a year, and this is taking forever. So I'm going to talk about the interest formula. So this is the formula for interest. And so I'm going to quickly explain what all the letters mean. A stands for the amount you have. And to figure out the amount you have, what you're going to do, you're going to take your P, which is your principal amount. That's your starting amount. So in this case, it would be the $2,500 that we started with. And you're multiplying it to this weird thing, which I'm going to explain in a minute. The one's always there. The R stands for your APR, your interest rate. The N stands for whatever you're compounding by. And then up here, the T stands for how many years they're going by. And the N is still the compounding by part. So let's talk about how you see it right here. From the beginning, we took the initial amount and we multiplied it to our interest rate, but not our yearly interest rate. Remember, we did the 15% divided by 12 because it was 12 months. That's this part right here. Your interest rate divided by whatever you're compounding by. So we did 12 on bottom because it was monthly. So remember, if it says monthly, n is going to be 12. So these are our n's, by the way. In our formula, those are the n's. So if it says we're compounding weekly, we divide our interest rate by 52 to figure out how much it gets each week. But since we were doing monthly, we divided it, the 15% by 12 to figure out how much for each month. So this is where you're multiplying by the interest rate divided by what you're compounding by. But then it has this 1 plus in front. The reason why it has this 1 plus in front is because each time, it's not like I only found the interest rate. Because if I multiplied and only found my interest, I would get this answer. But I needed to add on this 2,500. This 1 stands for 100%. So you're going to take the whole 100% of the amount you have, and you're going to add on your interest rate being divided by what you're compounding by. So this is this part right here, the middle of the parentheses, the inside, is this part where we were taking how much we had plus adding the interest. The 1 is how much we have, plus this is the interest part, the rate divided by the n. So if I were to trying to turn everything you see in this first step into this formula, 1 plus, my interest rate is 15%, but as a decimal, I do 0.15, and then I divide it by 12. And that's that middle part, and that's almost right here if I wrote 2,500 in front. Because then when I multiply that 2,500 into the 1, I get this 2,500. And then when I multiply it into this guy here, this is secretly 0.15 divided by 12 is just that 0.0125 that was our interest rate that we were multiplying by each time. So when I do this times the 0.0125, that was this math right here. So then when I multiply it in, I'm going to end up with this exact thing right here. So you take the amount you started with, you're multiplying it by 1 to get the whole thing there, plus what happens when you multiply it to the interest. And then you add those together to figure out how much you have right now. But here's the thing. That's only if I did it once. So if I did it one time up here, then I would get out the answer that I got here when I added them, which was this one. Now I want to multiply it to this 1 plus the interest rate again to figure out after another month what's going to happen. And then I'm going to end up with my answer after 2 months. Then if I times it by the same thing again, I'm going to end up with my answer after 3 months. And so I'm going to keep multiplying this parenthesis to my answer again and again because I want the whole thing plus my new percent rate. So remember how many times you multiply something becomes the exponent. So if I do it twice, a 2 would go there, and then I would get my answer here. Instead of having to take the new one and do it again, I could just change my exponent because that's what exponential equations do, right? Instead of having to take the one before it and multiply it again, I could just put it in a formula where how many times I multiply it by is my x. So now this represents any one of these three. Depends what x I put in there. So now this is my equation for my little situation. Because I take my principal amount. I multiply it to 1 so that I keep the whole thing, but I'm going to add on my interest rate after being divided into 12. And then up here it says to the power of t times n. Well, remember t standing for time, which is how many years have gone by. Because the question up here talks about after 5 years. So t, our time. So instead of x right here, they're going to be using t for time. The time is about the years. So if I put a 5 right there right now, they're going to multiply this to the principal amount 5 times. Well, so that's going to tell me after 5 months, because this is in months, because I was dividing that 15% by 12. So if I want to figure out how many months there are in 5 years, I have to take that 5 years and times it by 12 to figure out how many months has gone by. So then to get my actual answer, 5 times 12 up here is 60. I'm going to plug in 60. So now all I have to do is go to Desmos. 2,500 times 1 plus 0.15 divided into 12 power 60. So this would be my answer, $5,267. However, note it's the same thing if I wanted to divide, do 0.15 divided by 12 and get 0.0125. They'll give me the same answer. It doesn't matter. It also would have given me the same answer if instead of 60, I left this as 5 times 12. So you could do the math to simplify things, like this one, or you could not and leave it like this. You'll still get the right answer. So the answer here is, because the question at the very beginning is how much money will you have after 5 years? You need to respond after 5 years. Because it's a word problem that asks a question in words about a situation. You have to respond in words about that situation. So after 5 years, I will have, and the amount was $5,267 and 95 cents. So if I throw that money into a savings account, I don't touch it, I don't add any more to it, but they tell me my APR is 15%. In 5 years, I'm going to over double that amount. For free. It's just interest I get for free for letting them borrow my money for 5 years. All right, one more example. This one's a little different, but we're going to go to the fast way now. This one says you buy a car that costs $15,000. The APR for your loan, here I'm going to write that, for your loan is 12%, and it gets compounded quarterly. For whatever reason, you are unable to pay any money back on that car for 2 whole years. How much will the bank earn on you in interest in that time? So here's the truth. If you go 2 whole years without paying back a loan, they're going to come take that car from you. So they're going to take it, and you're going to owe them money. However, let's pretend that didn't happen, and let's just answer this question. So to begin, it's always easiest to make the formula. And the formula says to know how much I have, to get the amount I have, I'm going to take my principal amount. And how much is my principal amount in this situation? It's $15,000 because that's how much your loan starts at. That's how much you start with owing them. And then if I continue the formula, it's 1 plus. And then on top, my R, remember, is my APR. And what's the APR here? It says 12%, but you need to write it as a decimal. And how do you write 12% as a decimal? It's 0.12. And then divided by N, according to the formula. And N is how many times we're compounding it. How many times are we compounding it? It says we're compounding quarterly, which means how many times? Remember, quarterly means 4 times a year. Then, when it comes to the exponent part, the time that has passed, how many years has passed is it talking about? It's been 2 years. However, I need to multiply that to the fact that I'm doing this 4 times per year because I'm being compounded quarterly. Because then in total, in the 2 years, it'll happen 8 times. So now I can straight throw that into the calculator. So I started with 15 grand, 1 plus 12% being divided 4 times, power of 2 years times the fact that it's happening 4 times a year. So now my loan is $19,001.55. $19,001.55. So that's how much I owe them now. So the question says, how much money will the bank earn in interest? So how much of this was because of interest? Well, if you remember, I started with $1,500 that I owed them, and that wasn't because of interest, that was because of my car. But now, because I haven't paid anything on it, and they earned a bunch of interest, I owe them $19,001.55. So what am I going to do with the two numbers to figure out their difference? Remember, difference means subtract. So I'm going to minus the 15,000. That was because of the car. And find out that $4,001.55 the bank earned, or the car dealership earned, just because of interest, because I wasn't paying on it, and they were just collecting a lot of interest. So to write it as a sentence, in the 2 years, the bank will earn $4,001.55 because of interest. And then that's how you would answer that question. All right. So using all of these vocabulary words, exponential, interest, principal amount, APR, and compound, go ahead and tell me what you learned how to do in this lesson. And don't forget to try to use if-then statements when you're explaining.